Hello everyone, today we are discussing about CPU scheduling algorithms. CPU scheduling is the process of allocating CPU time to different processes. It is an important part of the operating system because CPU scheduling algorithms make the system more efficient, faster, and fairer. There are a lot of different CPU scheduling algorithms, each with its own disadvantage and advantages. But in this presentation, we will mainly focus on FCFS or first come first serve. However, I will be giving a short summary of the other CPU scheduling algorithms as well. Let's start with the two types of scheduling method, the preemptive and non-preemptive. Preemptive scheduling allows the CPU to be taken away from a running process and given to another process, even if the first process is not finished executing. Preemptive scheduling is more efficient and fair than non-preemptive scheduling, but it's more complex. Non-preemptive scheduling, on the other hand, does not allow the CPU to be taken away from a running process until it finishes executing. Non-preemptive is more simple, but it is less efficient than preemptive scheduling. When scheduling is preemptive or non-preemptive, consider the following when deciding if scheduling is preemptive or non-preemptive. Number 1. Switches from the running to the waiting state. Number 2. Switches from the running state to the ready state. Number 3. Switches from the waiting state to the ready state. And number 4. Process finish its execution and terminated. Only conditions 1 and 4 apply. The scheduling is called non-preemptive. All other scheduling is preemptive. Now let's go to the CPU scheduling algorithms. First of all is the shortest job first or SJF scheduling. Processes are scheduled by SJF according to their estimated execution times. The process with the shortest estimated execution time will always be scheduled first. The goal of this algorithm is to reduce the overall average waiting time. An example of SJF in real life is a to-do list. If you have a list of tasks to complete, you could prioritize the tasks based on their estimated time to complete. You would then start by working on the shortest task first. This would allow you to make progress quickly. Next is priority scheduling. Priority scheduling schedules processes based on their priority. As the name itself, processes with higher priority are scheduled first. Processes may be given priority according to a number of criteria, including their performance, type of process, or the user that submitted them. An example of priority scheduling in real life is the emergency room triage. When a patient enters the emergency room, a nurse or doctor triages them to assess their level of importance. Patients with more serious injuries or conditions that pose risks to their lives are given higher priority and are seen sooner. Next is the round-robin scheduling. Round-robin scheduling schedules processes in a round-robin fashion. It's a type of thing that they use on games that every team would fight all the other team. Every process gets a fixed amount of time quantum to execute the process. This algorithm ensures all the processes get a fair share of CPU time. Each process gets carried out repeatedly. An example of round-robin scheduling in real life are the traffic lights. Round-robin is used by traffic lights to allow each direction of traffic a chance to move. When the allotted time has passed, the light turns red in that direction and green on another. And the last one is the first come first serve or FCFS. This is one of the simplest scheduling algorithm. Processes are scheduled in the order that they arrive. This implies that the first process to reach the CPU will be executed first, followed by the second to reach the CPU, and so on and so forth. An example of first come first serve in real life is waiting to be served at the restaurant. Customers line up at the counter and are served in the order in which they arrive at the restaurant. So let us make a Gantt chart. Get the waiting time and calculate the average waiting time for first come first serve. So we have 4 processes here. P1 with a burst time of 12, P2 with a burst time of 3, P3 with a burst time of 25, and P4 with a burst time of 8. So here we have a time scale. The initial moment when all processes arrive is at 0. P1 is the first in line, so it will run from 0 to 12 because its burst time is 12 seconds. Once it's finished using the CPU, then we start with P2. It uses the CPU for 3 seconds, from 12 to 15 seconds. Then P3 uses the CPU for 25 seconds, from 15 to 40 seconds. Then last in the line is P4, which uses the CPU for 8 seconds, from 40 to 48 seconds. These boxes, things right here, is called a Gantt chart. It is used to illustrate how CPU algorithms works. Let us get the average time that these processes spent. P1 spent no time because it was at the first and placed on the CPU right away. P2 waited from 0 to 12 while P1 was using the CPU. So P2 spent 12 seconds waiting. P3 waited for 15 seconds before getting admitted. And lastly, P4 waited for 40 seconds to enter the CPU. Now we add all the waiting time and divide them to the number of processes. So 0 plus 12 plus 15 plus 40 is equals to 67. And we have 4 processes, so 67 divided by 4 is equals to 16.75. So that means our average waiting time is 16.75 seconds. First come first serve is the simplest CPU scheduling algorithm, but it is not always the most efficient. It works by allocating the CPU to the process that arrive first. This means that processes with shorter burst times may have to wait long time to be executed. Advantage of first come first serve. It is simple and easy to understand. It is fair to all processes. It does not need to prioritize processes. For the disadvantage of first come first serve, it can lead to long waiting time for shorter processes. It could also lead to convoy effect where a long process can block shorter processes from being executed. So to summarize this video, we talk about CPU scheduling algorithms. CPU scheduling algorithms are responsible for determining which process gets to use the CPU at any given time. We also discuss about non-preemptive scheduling, which cannot be interrupted while it is running, and there is the preemptive scheduling, which can be interrupted while it is running. Non-preemptive is not that efficient compared to preemptive scheduling algorithm. We also talk about some of the most common CPU scheduling algorithms, including the first come first serve, which processes in the order in which they arrive. Then we talk about short job first, which schedule the process with the shortest estimated burst time. Then we talk about priority scheduling, which schedules processes based on their priority. Processes with higher priority are scheduled first. Processes may be given a priority based on criteria. Then we talk about round-robin scheduling, which process in a round-robin fashion. Every process gets a fixed amount of time quantum to execute the process. The best CPU scheduling algorithm for a particular system depends on the specific requirements of that system. I hope you learned something from this video, and thank you for watching.